All right, in this video, I'm going to teach you about margin of error. So first you need to know about a population versus a sample. Of course, a population is a whole group of people or objects that you're interested in. And then a sample is going to be a portion of that larger group. Okay, so a margin of error is going to give a limit on how much the responses of a sample are going to differ from a population. So a lot of times if you hear the results of a survey, they'll say, okay, this particular candidate is up by 10% in the polls. But then they'll say something like, this survey had a margin of error of 2%. So that means really, if they're up by 10%, maybe they're up by 12%, or maybe they're only up by 8%. So that's the margin of error. It's like give or take that amount. That's what margin of error is. Okay? And here's how you calculate margin of error. It's this simple little formula, 1 over the square root of n. You need to memorize that. N, in this a simple version of the formula, represents the number of people who took your survey. All right, so 1 over the square root of n. Now, in another lesson, we're going to learn a more complicated, more precise way of talking about margin of error called confidence intervals. So you're going to have to differentiate between the simple margin of error and the more complex margin of error, which we'll talk about another day. All right, so looking at problem number 1. In a survey of 1,432 people, 26% of them said that they read the newspaper every day. What's the margin of error for the survey? So if you want to calculate that margin of error, which I will call MO for obvious reasons, that's going to be 1 over the square root of n. Okay, so that's going to be 1 over the square root of 1,432. So just put that in your calculator. All right, so there you go. Boom. All right, so this is the margin of error. Now, you want to write your margin of error as a percent, though, not as a decimal. So how do I convert this decimal over to a percent? You got to move that decimal point twice. So it's like boom, boom. Okay, so that's going to be 2.64%. And sometimes you have to round up the last number, but so 2.64%. All right, now give an interval that is likely to contain the exact percent of people who read the newspaper every day. So in the survey, the survey said 26% of the people read the newspaper every day. But the margin of error says that in reality it could be give or take 2.64%. So if we want a window that's going to contain the true answer, you have to add or subtract. You need to take this margin of error and do plus or minus with it. So we're going to take our 26% from the survey, and we're going to give or take 2.6. I think I'll just round to 2.6 for now. So we're going to give or take 2.6%. Okay, so let's see. What's 26 minus 2.6? 33.4? 23.4? Yeah, the other one wouldn't have made sense. All right, so 23.4%. And what's 26 plus 2.6%? 28.6. Okay, so that's the interval that's likely to contain the true percentage of people that read the newspaper every day. Okay, all right, it's just whatever the survey said, plus or minus the margin of error, give or take. All right, so in the end, you have to write in words what this means, sort of like I've just been saying over and over again just now, but this is the hardest for some of you, is being able to write me this little sentence. So just try to model your sentences after mine. So you would write something like this. It is likely that the real percentage of people who read the newspaper every day is between 23.4% and 28.6%. Okay, so that kind of a sentence is what I need to hear from you when I ask you to interpret in the context of the problem. You know, just write it up in a sentence mentioning what the problem was about. In this case, reading the newspaper every day. Okay. Do you guys have problem number 3 listed right underneath problem number 1? Like I do? All right. It probably just fit on the page that way, but I'll go ahead and go to number 2. Do number 2 by yourself real quick, and then we'll come back to it. All right. Is this what you guys got for number 2? All right. So you should have done plus or minus 1 over the square root of 800. That should have given you plus or minus 0.0354. Remember about rounding. Remember if the next number is 5 or higher, you need to round up. That's going to be really important in this unit. So remember to always round properly. So was that your question? All right, what's your question?
Does it matter if we use 3 numbers instead of 2? You don't like use 2.6 and then use 2.5.
Like on a test or a quiz, I'm going to just be prepared to do whatever I tell you to do. So here I didn't specify what to round to, 1 decimal place, 2 decimal places, but on the test I will. Okay, so you know if I say nearest hundredth, you know, or 2 decimal places, then give me that. If I say the nearest tenth or 1 decimal place, then just give me that. Just be ready for it. I could do either one. All right, so just sliding over here a little bit. So this should have been your final answer with the 16.4% to 23.5%. Any questions on that?
Do we need to go to the second decimal place or if we just go to the first one?
I didn't specify this time, so if you just did 1 decimal place, that's fine. Okay, number 3. Is number 3 a little different? In a poll about movie channels its customers prefer to watch, a cable company wants the margin of error to be 6.3%. How many customers would you need how many customers would you need to survey to get that margin of error? Okay, so this problem is sort of backwards. We're given the margin of error. So the formula is like this, where we know that the margin of error is equal to 1 over the square root of n, where n is the number of people that you survey. In this case, we're looking to see what is n. Keep your head up, Scotty girl. So we've got 6.3% has got to equal 1 over the square root of n. Now the first thing, Christian, we can't leave this as a percent to deal with the rest of this formula. We need to convert this to just a straight decimal. So Christian, how would I write 6.3% as just a decimal number? You move that decimal point to the left 2 times, correct. So that means what we really have is 0.063 is equal to 1 over the square root of n. So then it's just a matter of solving this equation for n. Any ideas of what my next move might be? Yeah, if you have a denominator, probably you're going to wind up multiplying both sides by the denominator. So we could multiply both sides by radical n. Okay, that way these radical n's are going to cancel out. So far, that gives me radical n times, you know what, I think I'm going to write it the other way. That gives me 0.063 times radical n is equal to 1. So what's my next move to get this n by itself? That's right. We're going to divide both sides by 0.063. Okay, so now we have the square root of n is equal to 1 over 0.063. And then, David, I already heard you saying it. How do I get rid of this radical? You square both sides. Notice, guys, see how I'm leaving it as 1 over 0.063? Don't try to turn that into a decimal. You're going to end up rounding, and you're not allowed to round until the end of the problem. So just leave it as 1 over 0.063. Leave it like that. So now I'm going to square both sides. And this should give me the answer, yeah? Okay, so let's check it out. So I'm supposed to be squaring 1 over 0.063. Okay, I get this. 251.95. Now, what does this n represent? N represents a number of people. So does it make sense to have this being a decimal? So yeah, let's go ahead and round that to the next highest person. No, because we need that margin of error to be, you know, as close to 6.3% as possible. So we'll just go to the nearest person. The nearest person. So that would be 252 people. So that would be your final answer. So number 4, a group of students surveyed the local community. See how smooth I read? Well, I'm a professional, of course. Why wouldn't I? About their favorite beverages. How many people were surveyed if the margin of error is 4.7%? So again, you're given the margin of error. Okay, so we know that the formula for margin of error goes like this. Margin of error is equal to 1 over the square root of people. Again, I am not going to put 4.7 in for the MOE. What am I going to put instead? 0.047 is equal to 1 over the square root of n. Do you remember the shortcut I told you where you could solve this in one step?
Switch the sides from A to C.
That's right. Switch the A and the C. All right? This 0.047 and the radical n, you can switch those out. So if you make that switch, which you're allowed to do, that's going to give you the square root of n is equal to 1 over 0.047. Do not put this in your calculator yet. Don't make a decimal now. Shh. Leave it like this. How do I make that radical go away? Square. Not technically, it's not the square root. We're squaring both sides. Put that in your calculator and tell me what it is.
4.293.
Okay? So we need to round that to the nearest whole person. So what am I going to put for my final answer? 453. All right? So that would be the final answer. Megan, strike one, sweetheart. Okay. Now, here's the last thing we need to know about. We need to talk about, no, Ari's okay. Ari's doing work over there. You're fine. You're fine. I need you to, the last thing I need you to learn is the difference between an observational study and an experiment. Okay, they're very similar. The difference is if a researcher is conducting an experiment, then there's like so many different experiments. If it's an experiment, the researcher controls what happens to the subjects in the experiment. All right, the researcher determines what the differences are, the different experiences. They're called treatments. All right, the researcher controls what the treatments are. In an observational study, the researcher doesn't control who gets what treatment. He or she just observes what is naturally happening. Okay, so look at these two examples, and see if you can figure out which one the researcher is controlling who gets what. And in one of them, the researcher is just observing and just seeing whatever is already happening. Rachel, do you have your phone in your lap? I'm just curious. Put it on my desk. Nice cover. Smooth. Okay, so let me read you this story. A scientist wants to study the effect that a nutritional supplement, like a vitamin, what are these animals? So it's like an animal vitamin. So a scientist wants to study the effect that this nutritional supplement, this vitamin, has on the growth of mice. The weight of each mouse is recorded daily. One group of mice, one group consists of mice that do not receive the supplement. They don't get the vitamin. The other group of mice, they do get the supplement. One group gets the vitamin, the other group doesn't. Okay? Now, is this an experiment? Let's do this. Give me a thumbs up if this sounds like an experiment. Give me a thumbs down if it sounds like an observational study. So you're going to do thumbs up if you feel like the researcher controls which mice gets what. Give me a thumbs down if the researcher just observes what the mice are doing anyway. All right, excellent. Put your hands down. Yeah, everyone was thumbs up on that one. That's an experiment. The researcher controls. These mice get the vitamin. These mice don't get the vitamin. Researcher controls that. That's an experiment. All right, I don't have time to write all that down, but because you're supposed to say why as well. It's an experiment because the researcher controls whether or not the mice get the supplement. That's what you would write down. Now, obviously the other one's probably going to be an observational study. So let's read it and see what an observational study sounds like. So, you want to study the effects that using a calculator has on the time it takes to complete a math test. So, you record how long it takes a student to complete the test. One group consists of students who chose not to use calculators. The other group is students who chose to use a calculator. So what makes this an observational study instead of an experiment? All right? Right, the key, I see you identifying the key phrase. All right? Students chose. Students who chose. All right? The students themselves, the subjects, chose what they're going to do. The teacher just recorded, the researcher just recorded the results of that. Now, I could easily turn this into an experiment if I reworded it and said, okay, this half of the class, I mean, this would be so unfair, right? But if I said this half of the class gets to use a calculator on the quiz, this half of the class does not get to use a calculator. And I'm going to see which takes longer. Now it's an experiment if I decide who gets which treatment. All right, let's stop there.